All right. So for the last three examples that we're going to take a look at, let's make a note for ourselves that this is going to be using log properties. All right, using log properties, and you can refer back to section 4.5 if you need a refresher on those log properties. Okay. All right, so I look at this equation and I say, oh my gosh, I have two logs. Seems like a really good time to use the condensing to turn it into a single log. And so if I were to write this as a single log, I would get log base 8 of x times x minus 12. That is going to equal 2. All right. As soon as I have this in a single log, note we might leave for ourselves, we're going to condense logs. As soon as we have it as a single log, guess what we can do? Now it's just like all the other questions we looked at. We're going to rewrite in exponential form. Right. So what's my base in this case? And what's my power?
The base would be 8, the power would be 2, and then it would be equal to x parentheses x minus 12.
Beautiful. Love it. Okay. If there is one thing that you make sure you know walking into Wednesday's test, know how to rewrite logs in exponential forms and exponentials in log forms. That will take you so far. Okay. All right. Well, now we don't have any more logs. Now let's see what we have. I think it might be beneficial to do a little distribution here. So we'll get 64 equals x squared minus 12x. What do we do in order to solve this now?
Subtract the 64, make it equal to 0, and then you do like the factoring.
And then we factor. All right. Part of this is intentional. I'm choosing questions where we have to practice our factoring. Okay. The other part of this is I don't want you to walk out of this class being like, I don't know, we did factoring for like 2 days and then we never used it again. That would give you a very false impression of how often we use it. Okay. All right, let's think about some clever ways that maybe we can split this. I'll give you a moment to think about how we might rewrite that minus 12x.
Sorry, my mic was being weird. A way that you could rewrite it is negative 16x plus 4x.
Okay. And if we did that and we grouped, like what's the greatest common factor here? And what's the greatest common factor here? I think we get x times x minus 16 plus 4 times x minus, whew, those two are the same, thank goodness. Which means that I actually have 0 equals x plus 4 times x minus 16. We can apply our zero product property. We'll get x plus 4 equals 0 or x minus 16 equals 0. We solve, we get x equals -4 and x equals 16. Take a moment. Some of you, I'd like you to pick -4. And I'd like you to take -4 and plug it back into the original and see what you get. And others of you, I'd like you to choose 16. Then you're going to plug that back into the original equation and see what you get. All right. So let's take a moment and do that checking to see if we have any extraneous solutions here. And once you have a yes or a no, like yes, this is a solution, or no, it is not, you could just send me a direct message so we can kind of start to see what we're seeing here. Great, I see some of those answers coming in. I'll give you folks more time, yes or no. It's not always a, how quickly can you answer this, all right? Everyone who sent me something so far does in fact have the right answer. All right, so if you sent me a message so far, you are good. You are understanding what is a solution and what is not. And if I haven't heard from you yet, I don't know. I don't know what you think yet. All right, I'll give you another 30 seconds to put your answers into that direct message before we move along to example 16 and 17. All right, I think general consensus is that x equals 16 is in fact an answer, whereas x equals -4 is what we call an extraneous solution. All right. Now I want to be clear on something here. If you do the work and all you do is write out x equals 16, I don't know what happened to the other value. So it would be important for you to show me and yourself that there were two answers, but one of them doesn't work. Okay, you don't have to write out like everything you put into the calculator. You just need to show me that you tried it and that it didn't work. Okay. All right. Let's take a look at example 16 over here. Give you a moment to think about that. Give you a moment to start it in the privacy of your own learning environment. And in about 2 minutes, let's take some ideas in terms of strategy. Okay. So take some think time for you. And then let's share some strategies. All right. So again, through the direct message, I'd like you to send me what you think you should do for the first step. All right, send me what you think you should do for the first step. All right, I have a couple guesses. I'd love to see some more guesses just to kind of see where we're at. All right. I think that sometimes we think, oh, it's so easy when someone is telling us what to do. And it's important that we spend some time in a space where we have to make those decisions for ourselves. Okay. So being able to make those decisions for yourself are probably a better indicator of how you're going to do on a test or how well you know something. Okay. Nice. All right. Now I am hearing from mostly the same people. And so if I'm not hearing from you, you're not losing any points for it, but I am concerned about your engagement in the class. Okay. So it is important for me that we're all sort of contributing to this effort, because if I only hear from people who are like, yeah, I totally know what's going on, then I kind of assume that everybody knows what's going on. And if I don't hear from you, it makes it really hard. Like you lose out on the opportunity to clear things up and to learn. Okay. And I don't want that for you. But what folks have been saying so far, I think is very accurate. We see a log on this side and we see another log on this side. And so what most folks are saying, which is accurate, is we're going to take one of the logs and we're just going to subtract it to the other side. And so in effect, what we get is log of 5x plus 1 minus log of 2x minus 3 equals 2. All right. Now someone even gave me the thing that comes after this step. As soon as we have this, now we can condense our logs. And in particular, we would end up with 5x plus 1 over 2x minus 3 equals 2. All right. Now, I sort of left an aggressive amount of space here. Why would I leave that space?
For the base?
Exactly. And what is the base in this case? Nice. Okay. Again, you don't have to write this, right? If you already truly know that that base is always 10 when there's not one written, don't write it. I don't need you to write that. But if I see mistakes from you and you're not writing that, then I have a little bit less pity for you. Okay. What is happening with the share? Hold on. All right. So we have a single log. We have a base. We're taking the log of something. We're good to go to rewrite it in exponential form. And in fact, we'll get 10 squared equals the thing that is being logged. 5x plus 1 over 2x minus 3. Now, we know that 10 squared is 100, so we can sort of do that part. But what I have is 5x plus 1 over 2x minus 3 equals 100. how am I going to start to get x by itself?
Could you multiply 100 by 2x minus 3?
So we'll get 5x plus 1 equals 100 times 2x minus 3. I love it. And now I think we're sort of on autopilot here. We can distribute. We can clump all our x's on one side. So I'm going to subtract 5x from both sides, but I'm going to add 300. And I'm going to get 301 equals 195x, which means my x is exactly 301 over 195. Now I'll leave you to check this. But this, when you plug it back in to example number 16, and please keep in mind, I don't want you to plug it into anything that's been simplified. You literally have to go all the way back to the original equation. Okay. All right. So let me pause here for a moment. Let's have example 15 and 16 on the same page for a moment. What kind of questions are coming up for us, if any?
I got one, Professor. Oh, go ahead.
You can ask first, Andrew. It's okay.
Okay. I this is gonna sound silly, but how do you exactly check your extraneous solution when you have -4? The equation I use, I feel like it's not actually the correct equation to use. So how exactly would you, if you plug 4 back into the original equation, how would it turn out for you? How would you do that?
So we plug it back in, log base 8 of -4 plus log base 8 of -4 minus 12 equals 2. And we plug that into the calculator, and if the left-hand side gives us 2, we're good to go.
Got you. So it's just we can plug that into the calculator. I got you.
Yeah, because when you do, as soon as you type things in, you start getting error messages.
Okay, so it's not like you can go through, because I went through and had the -4 multiplied by -16 once I did 4 minus -12. And then I got +64, which then would equal 2. So I was really confused.
Yeah, no, Avi, it goes back to like, you literally have to go to the original, like whatever form you were asked in, you have to answer it in that form.
Okay, so you have to plug it into the calculator as that form rather than factor all of it.
Exactly.
Okay.
Okay. Good. I'm glad that people asked, because I think that was a really valid point, right? Sometimes we do sort of just say, we hand wave you like, oh, just plug it in and it's fine. And then you're like, but I plugged it in and it worked, right? So we want to plug it in and literally just put it into the calculator. And if it doesn't work, it comes up with an error, and you've double checked that you typed it incorrectly, then that will give you the extraneous solution. Okay. All right. I think there was another question out there, or was it the same?
Oh, yeah. So I just had just a clarification. So we should leave the answers in fraction form, not decimals.
Yes. So one of the things that we're going to start to do as we move forward is that fractions are usually like 99% of the time way better than decimals, because the fractions will always be exact, but the decimals, some of us have some real bad rounding habits here. You just keep chopping things off and you get an answer that's like vastly different from what it should be. Okay, so fractions, yes, because it's more accurate, but also one of the things I want us to grow in this year is how comfortable we are with fractions. And that we can write an answer as 301 over 195 and be okay with that. Okay.
I had a question about the fractions as well. Are you big on rationalizing the denominator if we have like a square root?
Yes and no. When we get to some stuff with imaginary numbers, yes. When we start to look at trig in the second 8 weeks, yes. When we get to calculus, a little bit less so. 'Cause it
Okay, yeah,
turns
just
out-
'cause I
yeah.
asked because I think I saw one on like quiz 4 or something, and I was wondering if it's okay just to leave it in the denominator for that.
Yeah, as far as an actual question, hold on, I don't remember quiz 4. Oh, yeah, nope, you don't need to rationalize that one. That would be okay.
Okay, thanks.
Okay, thank you. All right, any other questions that are coming up right now?
Oh, and sorry, one more. Would you prefer the answer also on like, for example, quiz 4 to be in factored form, or do you want us to like FOIL out the answer?
Either one is fine. I think the purpose of those questions is more, do you know what to do with the property? So if you can show me that it's multiplying, that's great. That shows me that understanding. Whereas if you can show me it's division, like that shows understanding.
Okay.
All right, so we've got one last question to take a look at, and that is example number 17. Okay. So example number 17. We now have 3 logs. Okay. But it turns out that we can use the same idea where we're going to sort of move all the logs to one side. And it doesn't matter whether we move the singleton to the other side, or if we take these two and move it to the left-hand side. Okay. And genuinely, I don't think it matters one way or the other. And so because I'm feeling like I just want to move one term, I'm going to take the log of x minus 1 and I'm going to subtract that to the right-hand side. And so I'm going to end up with 0 equals log of 2 over x plus log of 3x minus 5 minus log of x minus 1. Now we need to pack this back up into a single log. The base here is going to be 10. Again, I don't have to write that, but it might be something that's helpful when I rewrite this in exponential form. But what is the single log expression going to be? And I don't need you to simplify it necessarily. Tell me what I'm multiplying or dividing, or what are we doing? Okay.
What do we multiply the 2 over x and 3x minus 5?
Yes, we would. We would multiply those two for sure because we have an addition between them. What will we do with this x minus 1?
Divide.
So if we just write this out, we'll get 2 over x times 3x minus 5 over x minus 1. Okay. My suggestion would be to go ahead and write it in exponential form right now. I know this is kind of gross looking. There's a fraction inside another fraction. Embrace the discomfort. It's going to be okay. All right. So if we write this in exponential form, we'll get 10 to the power of 0 equals 2 over x times 3x minus 5 over x minus 1. Ten to the 0 power. Seems like a nice number. A very reasonable number to say, no calculators, you tell me what it is.
1.
1.
1, good. So 1 equals this. All right, this is gross looking. I'm going to admit that. It doesn't look very friendly. But tell me what your ideas are. How are we going to start to solve this?
You could pass over x minus 1 to the other side.
Beautiful. Okay. All right. What else could we do?
You could convert the 2 over x times 3x minus 1 into 2 times 3x minus 1 divided by x.
Yeah. Okay. Now, what I really like about this step right here is you made less fractions, right? And sometimes even if we don't like fractions, if we can get rid of them, that sort of helps us move forward. Is there any way to sort of get rid of the fractions that are left here?
Multiply both sides by x.
Nice, nice. Okay. No more fractions. We had something that was really scary looking, but piece by piece, we got rid of all the fractions until we have just like an equation, everything is all on the same line, right? Now, we distribute and we can move everything to one side. And whatever method we choose to factor, zero product property, solution 1, solution 2. This is pretty common in terms of how factoring shows up, that like you might be working through a problem and then partway through, you'll need to use the factoring, right? So it's not that factoring is just going to be all by itself, but rather factoring will be a part of a bigger problem. And a lot of times those problems might be more complicated than the factoring. So it's nice if we spend some time getting really good at our factoring, then the end of the problem is kind of like that nice, easy home stretch, okay? It's okay if you're not there yet, but again, I want us to be there by December, okay? I want us to be there by December. I will leave this up to you to check and see if we have any extraneous solutions, all right? I think we had a good conversation earlier about just plugging things into there and literally typing that into the calculator rather than simplifying along the way, okay? So you'll just plug in 5, you'll plug in 2. If anything comes back not equal to the other side, you'll know that that's extraneous. But if it's equal, then you'll know, hey, that is a solution. Okay. And so that, my friends, is the end of chapter 4. All right, this is the end of chapter 4. I'm going to go ahead and stop the recording here.